Hello, everybody. In this video, I'm going to go through our lesson on using or use slope. And the first thing we really need to remember for this lesson slope, that's our rate of change of the graph. We oftentimes use that letter M to represent slope of a line. And that is found by calculating the rise, or your change in y values, over your run, which is your change in x values. And we write this often as our slope formula, y2 minus y1 over x2 minus x1. So this is our slope formula, super important. And we're going to use this in our lesson today. All right. Some other things we kind of need to know for this lesson. I want to talk about the parallel line theorem, which states that two coplanar non-vertical lines are parallel. This is our symbol for parallel. I could even write it out. They are parallel if and only if their slopes are the same, or if they have the same slope. Now, it said non-vertical lines because vertical lines are parallel to other vertical lines. So vertical lines are parallel. If you know the equation of two vertical lines, those two lines are parallel. And horizontal lines also are parallel to themselves or to each other. So if I have the equation for two parallel lines, those also are the same. Note that a horizontal line is a slope 0, though. So, okay, so that's our parallel line theorem. I also want to talk about our perpendicular line theorem. Which states that two coplanar lines, and there are two coplanar non-vertical, this is an N, two coplanar non-vertical lines are perpendicular if and only if the product of their slopes is -1. And that really means if we have slopes that are negative or opposite reciprocals. That's what that means. So if you have these two slopes that are opposite reciprocals, you multiply those two slopes together and you get a number that's -1, you know that those two lines then have to be perpendicular to one another. All right, so that is our perpendicular line theorem. And notice again, it talks only about non-vertical lines because vertical lines are perpendicular to horizontal lines. And vice versa. Horizontal lines are perpendicular to vertical lines. Let's talk now about some right triangles. So remember that a triangle is classified as a right triangle when it has a 90-degree angle, which really means that two of its sides are perpendicular. So there's really two scenarios here. We could have what is known as a right scalene triangle. And let's see how I do at drawing one of those. Not too bad, not too bad. So here's a right scalene. This will be triangle A, B, C. Oh, and it's a right scalene triangle because it has the right angle, and each side length is a different measure. So that's a right scalene, and then a right isosceles. Let's see how I do on this one. Instead of all of the sides being different lengths, two of the sides are congruent, or two of the sides are the same. So here in this right isosceles triangle, these two sides, AB and AC, are congruent, and then this opposite side, the hypotenuse, is different. But in either of these two scenarios, two of the sides are perpendicular, right? Segment AB is perpendicular to segment AC, which means the slope of AB multiplied times whatever the slope of AC is, that has to be -1. So if you find those two slopes, you multiply them together, you get -1. Let's talk about some different quadrilaterals now. So as a reminder, a quadrilateral is just any polygon with 4 sides. And the first quadrilateral that we are going to talk about is a parallelogram. So in a parallelogram, as the name kind of hints, we have these opposite sides that are parallel to each other. So opposite sides are parallel. So I'm going to draw an image here of a parallelogram. This will be parallelogram ABCD. This will be A, B, C, and D. So in this diagram, A, B, and C, D are parallel. And AD is parallel to BC. Which means the slope of AB, which remember slope is M, so I'm going to write this as M of segment AB, that is equal to our slope of CD. And our slope of AD, whatever that slope is, that has to be equal to the slope of its parallel segment BC. So the opposite sides are parallel, so their slopes are equal. And that is a parallelogram. Let's now talk about a rhombus. No, rectangle first. My bad. So we're gonna do a rectangle next. Come on. So in a rectangle, we have the same features as a parallelogram. So opposite sides are parallel. And we have four right angles. So let's look at a diagram here. I'm going to create a rectangle A, B, C, D. I'm actually going to make this corner A, B, C, and D. So the opposite sides are parallel. A, B, and C, D, oops, are two parallel segments. And BC and AD, or AD and BC are two parallel segments. So same as before, that means their slopes are the same. But now we also have four right angles, which means that segment AB and AD form to meet a right angle. That's one of them. So I know then that segment AB has to be perpendicular to segment AD. I know that AD and CD form a right angle. So AD and CD, oops, have to be perpendicular. They have to form a right angle. I know that CD and BC form a right angle. So CD is perpendicular to BC. And lastly, I know that BC and AB form a 90-degree angle as well. They form a right angle. So AB is perpendicular to BC. So we have all of these right angles. So I know then if these two lines are perpendicular, if AB is perpendicular to AD, then the slope of AB multiplied times the slope of AD, since they're perpendicular, that product must be -1. The slopes of AD and CD should be perpendicular. So the slope of AD times the slope of CD, that also needs to be -1. So each of these products needs to be -1. We multiply the slope of CD and the slope of BC, it should equal -1. And a lot of times you're really multiplying the same numbers together. And the slope of AB times the slope of BC also should be -1. And that will prove that there are four right angles. All right, let's now talk about a rhombus. So we talked about parallelograms. A rhombus thinking about what a parallelogram was, it has those opposite sides are parallel. And all four sides are congruent. So a rhombus is another type of a parallelogram, just like a rectangle is a type of parallelogram. And a rhombus, oh, no, that's not right. It's not quite what I wanted. Let's see, I'm just gonna try to freehand it. Has those four congruent sides, but opposite sides are still parallel. So A, B, C, and D, AB, and CD are parallel, and BC and AD are parallel, or AD and BC are parallel. But also we know that all four of these sides are the same measure. So the measure of AB, or segment AB actually, is congruent to segment BC, which is congruent to segment CD, which is congruent to segment AD, which means the measure of AB is equal to the measure of BC, which is equal to the measure of CD, which is equal to the measure of AD. And to find those measures, you would use the distance formula. And I'm gonna write that down below. So if you need to find a side length in the coordinate plane, you may need to use the distance formula, which is distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Just write it down and know how to use it. You don't have to memorize it. You can simply just write it down. This comes to us from our Pythagorean theorem. So if we think about the Pythagorean theorem for a right triangle, if I want to find this distance, this C, I can find the height, right? How many units, how many y values are between the 2 points, and how many x values are between those 2 points. And the Pythagorean theorem tells us that a squared plus b squared is c squared. So if I want to solve for this distance, this c, that would simply be the square root of a squared plus b squared. So I kind of flipped it backwards here. I have our distance is equal to x squared minus x1. That's like our b, or the bottom side of the triangle. And then this y2 minus y1, that's like our a squared. So it is really just the Pythagorean theorem, but I strongly encourage you that you just write this formula down. All right, the other thing I wanted to talk about was a trapezoid. So I'm going to write that down here. And in a trapezoid, this is key, only one side or one pair of opposite sides are parallel. So, looking at an example here of a trapezoid, this will be trapezoid A, B, C, D. And AD here is parallel to BC. So AB is parallel to BC, but AB, oh, I miswrote that. AD is parallel to BC. Felt wrong. AD is parallel to BC. AB, this side length here on the left, that is not parallel to its opposite side, right? AB is not parallel to CD. So now I know then that if I'm talking about the two parallel sides, the slope of AD is equal to the slope of BC. And in the other example, the two other sides are not parallel. So the slope of AB then cannot equal the slope of CD for this to be a parallelogram. or a trapezoid, sorry. I just looked down at my notes. So please let me know if you have any questions on these and make sure now that you go ahead and look at the examples.